Hey everybody, Miss Teacher here. We're going to talk about area of parallelograms. Now in 5th grade you learned about area of rectangles and you probably are already familiar with this formula, area equals length times width. But what used to confuse me, why does that idea of multiplying the length times the width, sometimes called base times height, why does that work with parallelograms? Now before we begin we have to make sure we can identify a parallelogram. How do you know you're looking at one? The following has to be true. The opposite sides have to be parallel. So for example, this line right here is parallel to that line, this line is parallel to that line, and the opposite sides have to be congruent. So this line is equal to this line is equal to this line. Now that would also be true for rhombuses, which are just special parallelograms where all the sides are the same length, and it would also be true for squares. Alright, so recall that quadrilaterals are four-sided figures. There are shapes that would not use this formula of area equals base times height that are quadrilaterals. We will be talking about another strategy for how you find the area of those. And this formula also does not work with trapezoids, which are quadrilaterals. That's a whole other formula which we're going to introduce a little bit later on. So the idea of base times height being multiplied together works for parallelograms which include rhombus, sometimes people call that a diamond, rectangle, and a square. So these are parallelograms, these are not parallelograms. All right, here's just some more examples that we'll talk about in class. What I want to emphasize to you is that everything seems easy at first when we talk about area, but once we start talking about areas of triangles and trapezoids and other things, you will be very mixed up, and you're going to want to go back and look at your notes on what the formulas are for the different shapes, because you can see here that there are different formulas that we would use depending on what shape it is. All right, so let's take a look at this first, because I think this is helpful to understand why we multiply base times height to find the area of a parallelogram. If I take this triangle and cut it off from that spot and move it over here, so in other words, take it off at this spot right here and move it over here, doesn't that form a rectangle? And if I was to find the area of this rectangle, wouldn't I be multiplying the length, which would be 9, times 4, which would be the height, which is 36? Now keep in mind we didn't take anything away, we just moved it to another position. Now if we take that same idea, I have this really great app that I really love, which I'm going to show you, it's right here. It has trapezoids, parallelograms, and triangles. And if we look at parallelograms, see how it lets you manipulate this, and you can turn it and rotate it. You can even have the height of the parallelogram be outside of it. What I did is I used this app and I created a parallelogram, and I just want to show you that idea. If you take the triangle piece off of one side and put it on the other side, do you see how that forms the rectangle? It works for any parallelogram, so we can try that with this one. We cut that triangle piece off and we move it over here. Do you see how that forms a rectangle? And that's true for any parallelogram, and you can create any one you want using this app, and if you cut off the one triangle and just slip it in on the other side, it forms that rectangle. Alright, so I do want to take a moment to just make sure we understand how do we know indeed that we're looking at a parallelogram as opposed to a trapezoid, because trapezoids are other quadrilaterals. These are four-sided shapes, and the difference really has to do with how many parallel sides you have. In the case of a trapezoid, do you see how they're using the blue to represent parallel lines? Well, if we look here and here, they're not parallel, so this would be a trapezoid and not a parallelogram. If we go back to a parallelogram, this purple line is equal and congruent to this purple line and parallel, and this is parallel to this, so opposite sides are parallel. Now don't be confused if they ever give you one where the height of it is outside of it. That's fine, because this yellow line, if we slid it over, that would still represent the height, but keep in mind the height always has to be perpendicular to what we're calling the base. So now that we understand that, and you're going to be confused again when we see other area formulas, you need to know, again, that the formula for a parallelogram is base times height, and if you happen to have a square, you can use the formula side squared. But if you did use this formula for the square, in the end you would really be just taking whatever the side is and multiplying with itself anyway and getting the same answer. Alright, so hopefully this helped you identify why we use this formula for rectangles and parallelograms.